Hi everyone, Mr. Rodriguez here with another video for you guys. Today's topic is 3D printers and some of the math related to them. So our objective is students will be able to visualize cross sections. Remember what cross sections are of a 3D shape from previous lessons. So students will be able to visualize cross sections of three-dimensional objects and understand how 3D printing works. So this is actually more of a lesson with a very clear kind of practical implication. The topics here are used by people who do 3D printing. So the first part here is actually something that you guys will do. So here you'll watch a video and respond to these questions. So that's something you'll do on your own. You could either pause the video and do it now, or if you want to come back to it after the video, that's fine too. But we'll be starting over here. So let's see, it says, observe the following right circular cone. The base of the cone lies in plane S. So plane S is this plane down here, right? And planes P, Q, R are all parallel to S. And plane P, this top plane, contains the vertex of the cone. There's a little top point there. So the first kind of question over here asks us to sketch the cross section of P prime of the cone by plane P. So we're basically, what this means is we're sketching kind of what the cone looks like on a plane. So the first one deals with plane P, so we're looking at this one. So we're basically trying to imagine here, what does the cone look like on this plane? So you'll notice that, as was said in the setup up here, it says plane P contains the vertex of the cone. So that means that this plane has the top of the cone. So actually, all that would be on this plane, so the only part of the cone that's on this plane is just a point. So that would be the cross section of the cone by plane P. Down here, if we call this number 2, it asks us to sketch the cross section R prime of the cone by plane R. So again, we look at this kind of plane R over here, and we're basically just kind of imagining if this is a like a plane that kind of cuts into the cone, what would the cone kind of look like on this plane? So really what you're kind of imagining almost is it would really just be like a slice, right? You see, it would kind of be something like this, right? Only one little sliver of the cone would end up on this plane, right? So it would just be a 2D shape. It wouldn't be a 3D object on the plane, right? It would just be a 2D shape. So basically, if we sketch the cross section, it would just be a circle, right? Actually, I can make that a little nicer. There we go. Beautiful. So it just ends up being a circle. Now, if we look up here, this is 3. It says sketch the cross section Q prime of the cone by plane Q. So again, this is our plane Q. So maybe I went a little out of order here. And here it actually draws it on this one for us. You see how it kind of is like a circle over here. But one thing you'll notice, and that you have to make clear when drawing it, is that, do you see how this circle on plane Q up here is smaller than the circle down here? So this cross section up here is smaller, right, than the cross section down here, which makes sense because the cone in some sense gets smaller as it goes up, right? So sketch the cross section Q prime of the cone by plane Q. So again, it would just be a smaller circle. Wow, my shape is so bad it doesn't even recognize it's a circle. There we go. So you see how that circle here is smaller than the one over here, right? Because it's from a higher part of the cone, right? It's from a smaller part of the cone. The radius right up here is going to be smaller than the radius down here, right? The area of the circle up here will be smaller than the area of the circle down there. And when also, just to clarify, when it says like Q prime, all that means is that we're just calling this cross section over here Q prime. This one was R prime, and this point was supposed to be P prime. It's just differentiating it from the whole plane. And then our last one, question 4. Sketch the cross section S prime of the cone by plane S. So we see plane S is this plane down here, right? And sketch the cross section S prime. So that's where the cone intersects with this plane. And we notice actually that the cone here, right, its base is on plane S, right? So the cross section down here is really the base of the whole cone. And we can see that this would be the biggest circle. So maybe I can try to draw one now that's bigger than. Let's see if it recognizes that. Uh-oh. Oh my gosh. Let's see. Can Mr. Rodriguez draw a circle? I need to take art class. I don't even know what happened there. Well, maybe we will take an L on this and just say it's a bigger circle than the one over here. So it is very hard to draw on this Apple Pencil here. So let's say, right, so this circle here is bigger than this one over here, which is bigger than this one over there. So question 2 down here says, what happens to the cross sections as we look at them, starting with P prime and working towards S prime, this one over here. So you'll notice first we start with a point. Then we get a slightly bigger circle over here, right? Right, because we started up here, then we went down to this one. We see the circle got a little bigger. And then when we go down to plane R, this one over here, we see the circle gets even bigger. And when we go all the way down to the base, we see what is supposed to be a circle is even bigger than the circle in R. So we can say the cross sections get cross sections get larger. Okay, so that's all for part 2 here. And when you end up doing your independent work down here for part 4, you'll see there are some problems that are similar to what we just did. So let's take a look at part 3 together. So now we're going to deal with something that we kind of see in physics oftentimes, but we'll cover it in math too. So we're going to be talking about mass, volume, and density. And we've already dealt with volume before, but we haven't dealt with mass or density yet. So the first thing we're going to do is we're just going to define them. So mass is the amount of matter an object has. The amount of matter an object has. And this is kind of similar to the weight. It is a bit of a distinct concept, but you can kind of think of it as the weight, how heavy the object is. You know, the more matter it has in it, the heavier it's going to be. But it is a bit of a distinct concept from weight. Volume we've done before, right? Volume is the amount of space an object takes up. Of space an object takes up, right? Kind of like how big it is, basically. So mass is kind of like how heavy it is. Volume is kind of like how big it is. And then density. Density is basically the amount of, let's define this here, the amount of matter per space in an object. And I think this is probably the toughest one to understand. It's kind of like, it's just how much matter, or how close the matter is together in an object. The easiest way to kind of imagine this is, if you take something like a rock, you'll notice even like a relatively small rock can be pretty heavy. That's because the matter in a rock is very close together. It's a lot of matter, right? We said mass is kind of like how heavy it is, right? The more matter it has, the more heavy it is. So an object that's very dense has a lot of matter that's tightly packed together. So a very dense object can be kind of small but still heavy. So if you imagine if you had a rock that was like, like a foot, like a square rock that was like, had a side the length of a foot, right? That's going to be a lot heavier than, say, a cake that's that size, right? Because you imagine the rock is a lot more dense than a cake, which is kind of fluffy, has a lot of kind of space in it. So that's kind of how you can think about those three concepts. And these concepts are very important for 3D printing. When you're 3D printing something, again, it'll be clear kind of when you see it in the video, you basically need to know how heavy the object is supposed to be, how much space it's supposed to take up, how dense it is. So these are practical ideas here. And again, with 3D printing, this will be clear after you watch the video if you haven't already. The way 3D printing works is it basically just takes the data from each cross-section, right? Say if we're 3D printing the cone up here, right? It basically takes the data for one cross-section, then another, and then another, and it basically just prints each cross-section on top of the other one. Now, there's also a mathematical formula that relates the concepts of mass, volume, and density. And that formula is basically density is equal to mass over volume. Make that V a little better there. So I remember that's literally what I said mass was, right? It was basically the amount of, what I said density was, right? It was basically just the amount of mass per space, or the amount of matter, right, per space. So that makes sense. One little way I kind of remember the formula is, you could almost say, maybe not the way I drew it here, but if you draw the formula again, you could kind of imagine that it looks a little bit maybe like a heart. The M goes on top of the V. Looks a little like a heart. That's kind of how I used to remember it. So let's look at an example problem here that relates to mass, volume, and density. So it says a block of aluminum occupies a volume of 15 milliliters. So our volume is 15.0 milliliters. Anytime you see things like milliliters, liters, that relates to volume, how much space something takes up. Right? Or like in the American system, customary system, you might say like a gallon, right? That's how much space something takes up. And weighs, so it has a block of aluminum, occupies volume 15, and weighs 40.5 grams. Again, grams is in the metric system, so instead of like pounds and whatnot, we're using grams, kilograms, and things like that. So that relates to how heavy it is, which relates to the mass. So our mass is 40.5 grams. And our question is, what is the density? What is our D? So all we do is we just set up our formula. Density equals mass over volume. So we just bring the D down, right? We don't have anything for that. That's our variable, what we're solving for. Mass, we know, is supposed to be 40.5 grams. And our volume is 15.0 milliliters. So if you take a calculator and if you just do 40.5 divided by 15, you get 2.7. So density equals 2.7. And if we remember our units here, density it's literally just going to be grams per milliliters, like that. So that's our final answer over here. And let's look at example problem 2. So example problem 2 says mercury metal is poured into a graduated cylinder that holds exactly 22.5 milliliters. So again, as soon as we see that milliliters, we should be thinking volume. So our volume is going to be 22.5 milliliters. The mercury used to fill the cylinder weighs 306.0 grams. So again, grams, we're thinking mass. And it's the same thing as we did up here, right? We have our formula. We're looking for density, so the D stays the same. Our mass is 306.0 grams, and our volume is 22.5 milliliters. So 306 divided by 22.5, that gets us 13.6. So our density is 13.6 grams per milliliter. And so, right, this object here in example 2, we notice is more dense than the one from example 1, right? It's just 13.6 grams per milliliter. So it's like 13.6 grams per space, right? And versus only 2.7 grams per space. And, keep in mind, here these problems were easy because I gave you mass and volume. If I gave you, I could give you density and mass, and you need to solve for volume. But it's basically just a matter of plugging in the numbers you have and solving for the ones that you don't have. So, for instance, if, let's say you got density and you had mass and you were looking for volume, then you would need to solve for V, right? You can multiply both sides by V, right? You get 12V equals like 4 or something. You could solve it that way. That's just a little side note there. So that's it for the notes here. So I covered kind of how you do cross sections, sketch cross sections, and I've covered mass, volume, and density. So now again, what you need to do, if you haven't already, is watch this video here and answer those questions. That'll make what 3D printing is more clear, since I didn't really cover it in this video here. And then come on down to part 4, and you have about, I think, 5 or 6 problems to work on down here. So, good luck, and as always, feel free to reach out if you have any questions or concerns. Have a great week, everyone.